Hello everyone! Today we're going to talk about electromagnetic waves.
But before that, let us first discuss our objectives for today's lesson. At the end of the 5-minute discussion, we should be able to describe electromagnetic waves and electromagnetic spectrum. We should also identify the different types of electromagnetic waves and cite real-life application of electromagnetic waves. So let us first define what is electromagnetic waves.
Electromagnetic waves are waves that are created as a result of the vibration between a magnetic field and an electric field. Therefore, EM waves are composed of an oscillating magnetic and electric fields.
EM waves are transverse waves, which mean that they are being measured by their amplitude and wavelength. From our previous discussion, we had learned that the highest point of a wave is known as crest and the lowest point is known as trough.
The electric field and magnetic field of an electromagnetic wave are perpendicular to each other. It is also perpendicular to the direction of the wave.
Electromagnetic waves travel at a constant velocity of 3 times 10 raised to 8 meter per second in a vacuum. Also, it can travel through anything, be it air, a solid material, or a vacuum. EM waves do not need a medium to propagate or travel from one place to another, unlike mechanical waves. Electromagnetic waves can be split into a range of frequencies. This is known as the electromagnetic spectrum. So now, what is the electromagnetic spectrum? The electromagnetic spectrum is the range of all types of EM radiation that travels and spreads out. Electromagnetic waves can be separated into 7 distinct groups in the spectrum. Those waves with a very short wavelength will have high frequency and high energy, while those waves with a very long wavelength will have low frequency and low energy. Let's talk about the different types of electromagnetic waves.
Radio wave has the longest wavelength among the EM spectrum. One example for this is the wave that is emitted by your radio station to bring music to your radio. Also, it can bring signals to your television and even to your cellular phones.
It has the longest wavelength of about 10 millimeters but has the lowest frequency of about 30 billion Hz or 30 gigahertz. Microwaves fall in the range between radio and infrared radiation of the EM spectrum. These are used for high bandwidth communications, radar, and as a heat source for microwave ovens and industrial applications. Their frequencies ranges from 3 GHz up to 30 trillion Hz or 30 terahertz. Their wavelengths vary from 10 mm to 100 micrometers.
Infrared lies between the visible light and microwave in EM spectrum. One example for this is the night vision goggles that picks up the emitted infrared light of our skin and from objects with heat.
Visible light lies between infrared radiation and the UV rays in the EM spectrum. Its frequency ranges from 400 terahertz to 800 terahertz and wavelength of about 740 nanometer to 380 nanometer. Our eyes can detect visible light like in fireflies, light bulbs, and stars which emit visible light.
Ultraviolet rays are the type of electromagnetic wave that comes from the sun.
Ultraviolet radiation has frequencies of about 8 times 10 raised to 14 to 3 times 10 raised to 16 Hz and a wavelength of about 380 nanometer to 10 nanometer. Its range in the EM spectrum lies between visible light and X-rays. UV radiation is emitted by the sun and is the reason why our skin gets tans and burn. It has numerous medical and industrial applications, but it can damage living tissues. X-rays has wavelengths of 0.01 to 10 nanometers, corresponding to frequencies in the range of 3 times 10 raised to 16 Hz to 3 times 10 raised to 19 Hz. This lies between the UV rays and gamma rays in EM spectrum. X-ray is useful in checking for fractures or broken bones and spotting pneumonia and other medical uses.
Lastly is the gamma rays. This type of electromagnetic wave has the smallest wavelength but has the highest frequency. It is used for medical purposes for killing cancerous cells.
Doctors use gamma ray in imaging to see inside your body. It is also useful in killing cancerous cells. Although being exposed to gamma rays can cause serious damage to human health. It has the highest frequency among the EM waves but has the shortest wavelength. So that's all for our lesson for today. Hope you have learned something.